All right, so in this video, I'm going to walk you guys through quickly. I'm just going to do the first two examples of how to work out the two-step conversion. So this connects what we did yesterday into today's lesson. The one thing I may encourage you to do is I had students draw a map, so to speak, where it just gives you a little bit of sense of direction in terms of how to complete conversions and if it needs one or two steps. So I'm just going to set that up here at the bottom of the page. So yesterday we started with the mole and we connected it with two conversions. We connected it to mass and we connected it to particles. There's a third connection, which is volume. We'll talk more about volume later on. A couple things I want to point out is units for this. So mass is always going to be a unit in grams. Particles, we have three options. We have atoms, molecules, or formula units. And again, mole is measured in a mole. So yesterday, what we worked through is connecting mass to mole. That was kind of the second half of the notes. And the part that connected these two was the molar mass. So in order to connect these two, you need to know the molar mass. Vice versa, and I'll get the paper straightened out here in a second, to connect moles and particles, or particles to moles, we use Avogadro's constant. Okay. So where we're at today is that we were able to complete this in one step and this in one step. What we're going to work on is connecting these two, but there is no direct conversion between mass to particles because different elements have different masses. So whether you're describing an element or a compound, they each have their own unique mass. So what we do is we have to connect the two through the mole. So this is why they're two-step problems. In this first example, it asks us to convert 83.2 grams of chlorine to molecules of chlorine. So no different than yesterday, our given is the 83.2 grams. Now be careful here, chlorine is Hoffenkleiber, therefore it's Cl2 for the formula. That is going to be important for molar mass. When we go to find the molar mass of chlorine, we would have that chlorine, there's two of them, and then on our periodic table, we would find it's 35.45 grams. So when we work it out, we get 70.9 grams per mole. Why I need that information, and I kind of got ahead of myself, is we're solving for molecules. So the very first thing that we need to get to molecules is actually to get it to the mole. And what takes us from mass to mole? It's the molar mass. So what we're going to do here is set this up where I'm going to keep 70.90 grams in the denominator to divide to make those units cancel. 1 mole will become my numerator. I can go ahead and cancel those grams, and I can see I've changed to moles. Again, I know that I'm not done because I want to count this in particles being molecules, and that's going to be done through Avogadro's constant. So from here, we got one more step. Moles is my numerator, so that means moles will go in my denominator of my second conversion factor. Avogadro's constant will go up top. Now you're ready to solve. To solve, you can do a couple of different things. What I would do on my calculator is I take 83.2, divide by 70.9, hit enter, times by Avogadro's constant of 6.022 to the 23rd. With 3 sig figs, I got a final answer of 7.07 times 10 to the 23rd molecules of chlorine. So again, it required 2 steps because I was going from mass to particle. In number 2, this really should say how many grams, that was a typo on my end, are in 3.34 times 10 to the 34th formula units of copper 2 hydroxide. So we're doing the opposite here. We're starting at particles, wanting to end at mass. Like problem 1, this is going to require 2 steps to solve. So I'm going to go ahead and start with my given of 3.34 times 10 to the 34th. And we're solving for formula units, or we have formula units, I should say. I want to point out we're talking about copper 2 hydroxide. So that copper has a charge of +2 because of that Roman numeral. Okay. Hydroxide is OH minus 1. So we get Cu OH in parentheses with a 2. That'll be important when we get to the next step of coming up with our molar mass. But again, if you follow your map, we're at formula units. We need to convert to moles, and the only way to do that is through Avogadro's constant. So I need to divide by his constant and multiply by 1 mole. Okay. Formula units eliminate. I'm now at mole. I want to solve for grams, so we need to go through molar mass to solve for mass. That's why that formula is important. So when we go to list our inventory, we have 1 copper, oxygen we distribute in, so there's 2 of them, and hydrogen has 2. You would then use your periodic table to come up with their individual masses. Copper is 63.55, oxygen 16, hydrogen is 1. So we multiply and then add all 3 up, and 97.55 grams per mole is the unit there. Looking at what I have for my conversion factors, I have mole here, therefore 1 mole will be my denominator, and 97.55 is my numerator. Again, how I would type this in is I would take this value, my given, divide by Avogadro's constant, hit enter, multiply by 97.55. With 3 sig figs, I got an answer of 5.41 times 10 to the 12th grams of copper hydroxide. Again, not all problems require 2 steps. The ones that do not require 2 steps are if you have mole and you're going directly to mass, or mass to mole, moles to particles, particles to moles. Those are all 1 steps. But to get from mass to particle, like what I introduced, vice versa, it will always require 2 steps.